Hello. So it's been quite a while since I worked on this. I think it's been about a month. Um, but we're just gonna get to it and hope I'm not too lost. I did leave one sort of helpful comment here. Left off at storing the sound timer. Yeah. I should probably pull up the documentation here. Well, this page is helpful. Although I think I copied a lot of the instructions into here. But okay. Store sound timer. Store sound timer. Oh, set sound timer to VX. The opcode 18. Yeah, 15 is delay timer, 18 is sound timer. That comment was worryingly wrong. That's fine. We do have the tests for them here. Set sound timer is failing, which is what we want because the code for it isn't there. All right, I did swap out the Rust extension I was using. I was using the one just called Rust. That was apparently wrong. There's Rust Analyzer, which also got pulled into the official Rust namespace for VS Code extensions. Yeah. So that's that. It did autofill in a unit there. That's something. Water. All right, so decodes. And now we just need to write the actual code for it. Wait. Oh, it's all implied. Yeah. That's fine. All right, so that test should run, which means only 3 should be failing. Hey, only 3 are failing. Okay. That was easy enough. What else did I write tests for? Binary coded decimal, load and store, multiple registers, okay. Why was sound timer missing? There's other... Okay, that's right. I'm skipping these because those are a little more in depth. gonna get all the tedious ones done first, and then think about what the heck I'm gonna do for those. So I should put that in there anyways. I'm gonna turn this music down a little bit. There. Address of font sprite into VX. No. Into I for the sprite VX. For the font sprite VX. That's after add index, right? Yes. So we can call that font index. We're loading the address for the font into the index register, I think. That seems like a good name to me. Naming things is hard. Font index. Index font. And it's from an arbitrary register, right? Yes. Oh. Put that under comment. X 29. Oh. Yeah. That test is gonna... Actually, there is no test for that, is there? What's wrong here? Oh, why is it complaining there? That's an odd spot to complain about that. Okay. So it doesn't actually do anything, but it's accounted for. Okay. One more instruction done. All right, binary coded decimal. Actually, no, this isn't that bad. It can be brute forced because there's only ever going to be 3 digits. So x33. Where is it stored? Store it at I through I2 plus 2. Yeah. That's a terrible comment. There we go. All right. Fine. Go to decimal. Register. Oh, this is the implementation part. Let's get the easy part out of the way first. I didn't pull in something called binary, did it? It did. Undo. Undo. There we go. Okay, so binary coded decimal. So the value can only ever be an 8-bit integer. I'm fairly certain they're positive integers as well, although I should double check. One byte data registers. Doesn't actually say. Unsigned. Yes, they are positive only. They're unsigned. So 0 to 255. That means there's only ever 3 digits. 255 is the largest number. So what we can do is we can take the we can just divide it by 100, 10, and 1. Yeah. Yeah. Yeah, maybe. Is there a better way to do it? So I think I will have to actually loop through it, because I do have to subtract out what's in there, or what's been taken. That way, when I divide by 1, I don't get 255. I just get the remaining 5. Or no, I don't have to divide. There's modulo. So yeah, divide the number for the value, modulo goes into the rest of it. And divide, modulo, and then divide. Not even divide, you just take the last number. Division by 1 is just the number. Okay, so We need to actually get the register. Let's wrap this in parentheses or a bracket that's gonna be a long one. This is gonna look a little ugly, but equals let's get the remainder of dividing it by 100 and then divide it by 10. And then is the really, oh, you know what? No, it doesn't have to be ugly. Guess what's divisible by 10? 100. So I just have to do modulo 10. Yeah. Yeah. Right? Does that make sense? All right, so the first digit, divide by 100. So if it's 255, we get 2. The remainder of 55, which here we modulo 100. So if it's 255, we get 55 divided by 10, 5. And here, again, 255 modulo 10 means we divide 25. Left over from that is 5, and we just store that. So a little ugly because there's 4 division operations, but it's binary coded decimal, probably. There's one way to find out. Let's test that. Oh my god, it worked. Although this is one that can have multiple test cases. Where is it? What's wrong here? Oh, it's never used, but that looks like it's in the wrong spot. Yeah, I'm gonna beef up this test a bit. So what would be another good number to test? Let's get something with some zeros in there. 100. 100 in binary is, sorry, 100 in hexadecimal is something. Whatever, I'm not doing the mental math. Not date, programmer. Here we go. 100 x 64. Wait, I could have just done that. Why would? Ah, yeah. Wow. All right, we're just gonna put another. One of those in there, so it does 100. So step again. I mean, actually, I could also just reset the program counter. Yeah. Got C equals back to 200. Oh, I'm satisfied. 2 passing test cases now. Function is never used. I feel like this is leftover from something else. Can I force a refresh of this? Because that's getting a little annoying. All right, that was binary coded decimal. And now the bulk store and load. So V0 to Vx, starting at I, and then I is left at I plus x plus 1. So it's left at the spot after the last one. So if you do V1, it would load V0 into I, V1 into I plus 1, and then I would be set to I plus 2 when it was done. And it's been so long since I've touched assembly, I don't know what the similar name would be, but that's fine. We're just going to call it bulk. And I didn't even look at what the opcode was. 55. And we're in 5. Look at all the other ones. It's register X. It's after binary code decimal. Man, this is ugly. There was no comma there. Did there need to be a comma? I already had brackets. Bulk store register. Okay, can I store? Can I just drop an equals in there? I don't think I can. Is there a simple way to do this? I asked about a systems programming language. Want a, and we'll just loop for in 0 to inclusive x, no register. No. There we go. I, no, that one at self.I equals b x. Actually, we're going to wrap this whole thing in more brackets. Hey. So close. Oh. Formatting. Right? That looks right. Let's go all the way down to the test. Store register bulk. Alright, so we're doing 100 minus I for the values of the registers and then testing that they are 100 minus I. And we are going to test CPU I is F10? I believe so. I think that's the math. Because it's at F00. You put F values into it, which means we're actually wrapping around to 0. Yeah. X F10. Math. What's wrong? What? Well, this will yell at me in a more intelligent manner. Oh. And so it did. Two failed. Store register bulk. Assertion failed. Left 85. Right 100. Scroll all the way down. So I 0 to 15. B is 100 minus I. Means it should be 100 at the first one to 85 at the last one. So if we do the same thing, just iterating through memory, 100 minus I. left equals right. So left, it was expecting 85. No, it was expecting 100 and got 85. Why? Well, do I still have it dumping everything out? Let's find out. Oop. You might be missing a little. Wow. That's a hell of a comment. That's kind of exactly what I wanted to do. Although, yeah, use debug formatter. Right, registers are 100 through 85, and I did not dump the memory. Let me guess. I deleted that out. Yes, I did. And all that memory is gone of what I did. Okay. Let's see. It's mem. Formatting is and self mem. Yeah. Let's see if that. Oh, it does work. Where did I put this stuff? Why is only 85 stored? All right, something's definitely screwy. Take another look at this. For X in 0 to register. Oh. That would be helpful. I just kept overwriting the same spot in memory. Look at that, the test passes now. And we're gonna comment this out. Okay. Much better. Look at that, now we have to do the opposite. Load bulk. Oh, bulk load. And is I set to something afterwards? Same thing. I is I plus X plus 1. What's it doing? No, it's all in this file. What am I doing? And that's it. That's bulk load. At least that's what it should be, I think. Yep, everything passes. Great. Except we're not able to draw sprites. We're not interacting with the keyboard at all, as we should be. And we're not making sounds, which is probably for the best. The sounds are a single tone played for a number of 60 hertz units. We also don't have any sort of UI whatsoever. Which maybe that would be a good place to start. I don't know. By the way, let's see just to make sure. 55 to 89 is 30 or 35, right? Seven, 8, 9, 20, 2, 3, 4, 7, 8, 9, 30, 1, 2, 3, 4, 5. 35 opcodes. Wow. That's a lot of opcodes. 10, 4, 5, 6, 7, 8, 9, 20. 2, 3, 4, 5, 6, 7, 8, 30. 2, 3, 4, 5, 6, 7. That's right, because I have this test one here and the catch-all for invalid opcodes. If for some reason there's an invalid opcode, I have no idea what the original Chip8 would do. We're just gonna hard crash. Just oops. Sorry. It's all broked. What is here? Field is never read. Stack. Why is that? This clearly has not updated. How do I force it to update? Come on. No. Okay, so what next? The instructions are done. You can... we can make the screen. It doesn't have to actually be visible, because it can just be an array. Because that's essentially all it's going to be. And then we draw from that array. Yeah. Another bit here. This will be green. How big is the screen? Guess what? It's a bool. That's what we've got here. Because it is 0 or 1. Although is a bool 8. Do we want to get screwy and deal with individual bits? Not immediately. We can later, but for now, we'll use an array of booleans. (64 by 32 pixels). What is 64 times 32? A whopping 2,048 pixels total. That is that's less pixels than are in a single row of this monitor. 20 what is it? 1440 vertical is 20 what? Horizontal. Now it's bugging me. 2560 horizontal. Yeah. Yep. Wouldn't even fill a row. How far we've come. All right, so the screen's roughly 2 kilobytes. And that's the most data out of anything. Oh no, memory's 4 kilobytes, that's right. Up to 4 kilobytes. Oh, we haven't said it. No, 2040. And I already don't like false here. So yeah, 0. Not a valid Boolean. But oh, I know what I can do. And there are 32 of them. They're, say, 64-bit integer, and there are 32 of them. Perfect. Oops. No, that should be false. It should be 32. Oops. Now we can write all of the logic for drawing to the screen. We just can't draw to the screen yet because there's no graphics yet. So where is a... Right, I don't know where the font sprites are stored. Just wait for key presses. Yeah, still there. Draw sprite? Where's draw sprite? Draw sprite. I didn't even write a test for it, so it should be under. It should be right above this. And this we can do in 2 passes. Wait. Yeah, we can test the functionality by drawing the same sprite at the same location twice to verify that 1, all of the pixels are set, and 2, we draw the same sprite over that, all the pixels are unset because that's how collision detection works. If you draw a pixel onto an already set pixel, it's unset because everything is exclusive OR. XOR? Zor? Zor? Wait, is that the guy from... yeah, whatever. Okay. What is the opcode for... DXYN. Draw a sprite at VXVY that is n bytes long and starts 9. This uses every register we have. All right. So n draw sprite at X Y. Sprite is n bytes long. And sprite info starts at I. Now, how do we do 2D? Sprites are always 8 pixels wide, with the height ranging from 1 to 15 pixels. That doesn't help too much. So what does that mean? Does that mean that the sprite is always... So n is how high the sprite is, because it's always 8 pixels wide. I assume that means 1 byte is a row of the sprite. And then does n just determine how high it is, and do we just draw it down? That makes sense to me. I don't I don't know if that's how it works. And they can only be up to 15 pixels because that's all you can represent in this instruction, with an F in the last spot. Right. Okay. Oh, they have... There's an example of the sprites. That's actually helpful. Yep, they're drawn top down. So that's 15. Wait, F0. Oh no, the first 4 bits are set. I see. Yeah. Okay. Yep. makes sense. Perfect. So we want to draw x will be 0. No, we need a different register, so v1 will be y. And how many bytes long? 5. We will use one of the character sprites. Use the one for 1. Yeah. So in order to do that, we need to fill. We need to add this into memory. Clear that is a -1. Okay. Oh, we should set I first. Set all that stuff. CPU E 0. We will draw the sprite starting at. I mean, we'll do 0, 0. That's easy enough. I will be at. What am I doing for some other stuff? Where's I and some other stuff? F0, 0. It's good. That's far enough away from everything else. I can actually wrap up the font sprite load test into this, because this is going to be font data. However, I need to actually write that up first. So we'll hard code it in. Why don't I just be intelligent and copy and paste? There's something wrong with that line. All right. Now, does this say anything about... Nope, doesn't say anything about where I gets left. So I assume it's left where it is. So that's the sprite data for A1. Drawing just 1. Then we're gonna have to probe the screen, and that's gonna get funny. I'm gonna have to figure out what numbers actually represent the screen state at this point, which is something that's kind of a pain to do. Great. What have I done? So I just slap this in programmer mode. Can I? Oh, it's got a bit mode. Excellent. For trying 0, 0, let's see, we have 2, 0. So the first, that should be that. And hex is a number. Sure is. Screen 0 should be that. Actually, it's just going to be that for everything. Yeah. Well, no, not that exact number, but just the original number with 6 more zeros added after it. Glad I figured that out. So this is 60. Those, that other one. I can't count apparently. And then 4 is 70. Semicolons missing everywhere. Okay. Something is very wrong. Expected bool found U64. Why is it telling me this down here? Okay. Expected bool found U64. What? What? Why is it expecting a Boolean? I updated that, right? CPU, U64. Screen is never read. Yeah, I know. Why does it think it's a Boolean? Also, what does it think is a Boolean? I don't know where it's complaining here. Format argument must be literal. Huh? Format argument must be a string literal. What? I'm not printing anything, am I? Okay. What's wrong here? Expected bool found U64. Okay. What? What? Oh. I'm using the wrong insert. That'll do it. Hey, look, it failed. Because that's not doing anything. Great. Also, what we're going to do is... reset the counter step again. And assert that everything is 0. Yeah, you can coerce that. Actually, wait. It's just for consistency's sake. And all right, so it's just set to 1. So that we F set to 1. Oh, all right. Granted, none of that's going to happen because none of it's been coded. But there's the test. And now that we have the test, all right, draw sprite is there. Draw sprite is here. It just says we're drawing a sprite. Doesn't actually print that out. Drawing sprite at 0, 0 of size 5 at F0, 0. Well, all that information is correct, but we're not printing the line anymore. We're doing it. We're gonna draw the sprite. All right, so let x equal v register x. Let y equal set.v register y. Okay. Yeah, okay. Yeah, we'll do it that way. Sure. Sets the x and y. And for 0 to size. Okay, we need to get the 8 bits of sprite data we have into 64 bits and then exclusive OR it. Well, one more step in there. course, it's 64 bits. And then shift it left or right, depending on something. Or we take that byte, set it as the first byte in a 64-bit integer that's all zeros, and then we right shift it to the right spot. That makes a little more sense. If only I had some way to like describe this visually, it would make a bit more sense. All right, let right equal oops for s in s. So we can start it. Yeah, we'll start at 0 and it will go up to size, well, -1 will be the last number. Self to I plus s. All right, so that is the row of sprite data. Is there a way to do what I'm thinking of doing? So we're starting from a U8. Can we get it to a U64? Convert a U8 to a U64 losslessly. That's nice, but bullshit left. I don't want to ship. I don't think. Shift right. No, I don't need shift right. Or shift right assign. Try from. Nice. So, and we're going through that again. Okay. Well, let's see. Does U64 have any helpful methods? Can I create a U64 from a bunch of U8s? Can I shift left negative and have it actually shift right? Hold on. No, because it takes an unsigned integer for shifting. Darn. Okay. I mean, I could just shift the whole sprite left and then shift it back right. That doesn't make a lot of sense. There's gotta be a better way. Oh, I can make one using from BE bytes. Yeah, hold on. Make sure we're using the same one. Yep, BE bytes. Big Endian. Okay, this is going to be ugly. Let's sprite equal. E-bytes. Yeah. Yeah. That's great. This is mutable, because why not? And then out of here, documentation. I don't need the documentation on mutable. Right? Right. Oh, X. Yeah. Okay. So we have made a representation of the entire row for the sprite, where every other pixel is 0. We have then shifted the number right into the X position. So if our sprite was just a single pixel for the first point in the sprite, so the first pixel is set and everything else is not set. If it's at 0, 0, we would set that pixel in the top left. And how we would do that is we would take the first U64 of the screen, well, of the representation of the screen, and then the first bit of that would be set. If we want to draw the second bit, but use that same sprite, we now have to shift right one. Or sorry, if we want to draw on the second pixel, which would be an X of 2, an X of 1, not 2, or 0 indexed. So we want to draw at the screen position X1. We need to shift it right 1. And then exclusive OR that entire monstrosity with the actual screen. It's weird, but it works. It's something you would absolutely not do on modern machinery, I don't think. I want to draw this pixel. Give me the entire row of the screen so I can draw this one pixel. Okay. That's, yeah. And where does Y come in? Where Y comes in, let row equal dot screen of for Y. And then, oh man, that is a type you have put there. Fairly certain that should just be a U64 for row. It should not be all that. Although maybe it's doing it because Yep. That's why it was freaking out. Then we can exclusive for them together. And let's see. Of course, this is not helpful. So, okay, whatever. Performs the exclusive OR operation. Yeah, that's nice. I want to know. Returns anything. Returns a U64. XOR assign. Assigns it to, right, assigns it to it. I need to remember my binary logic here. Okay. Well, I mean, I can exclusive OR it easily. X, does X need to be a U size? I don't think it does. You can shift right by any old number, I think. Doesn't have to explicitly be a U size. Okay, so Y is U size, so screen, Y, which we can get rid of this. Equals. Up that screen, Y. Use the OR. Right. We'll just do that up there since we're assigning it. And then it doesn't have to be mutable. Okay, what do you think is wrong here? Unused variable row. Yes, actually, yes, that's correct. But there is the one thing we have to do, and that's figure out if anything was set. And to do that, I need to remember binary. First things first. We explicitly set that to 0, and then in here we check if we've actually unset anything, which oh, yeah. We will If we mask it with the sprite and compare it to the sprite, then we have unset something. That is an ugly way of doing it, but whatever. Yeah. Because if we've drawn the sprite to the screen, and we then take the screen and do a bit mask with the sprite, everything there should be set. If anything there is not set, it will not be equal to itself, which is a roundabout way of saying at least one pixel was unset. So let's see how this goes. Oh. Left. Right. Yeah, that's not that helpful. Okay. Format. Can I format as bits? Binary in STD format. Well, look at that. Hey, it even has an example. Cool. All right. That is now covering everything that I wanted to actually look at up. Value, get out there. Format args. Self dot screen. Is this gonna work right? I don't think this is gonna work right. But I don't think that's quite right. Also, I need to actually print that out. Oh, wherever that test is. Did not compile. Nice. Remove these parentheses. The only traits are. Oh, binary is only lowercase. There is no uppercase binary. That's should be obvious. Would you like a uppercase 0 and 1 or lowercase 0 and 1? Trait bound. It's not specified required because the arguments of him, but binary for it. Not sure. Probably still broken. Yeah. Wait, what? Binary is not implemented for an array. Yep. That's what I thought. But I really need to see the binary values of the array. Um, takes a debug. Not quite what I was looking at. This is debug struct from formatter. Wait, so this is formatter. Creates a debug struct builder assigned for debug. Yeah, okay. Struct. Field. Okay, debug. The debug is the formatter. Great, performance. Whatever. All right. Nope. Taking too long. We're just gonna go all the way back down to here. All right, what is the comparison here? This number. It's fine. I didn't want that to go to the terminal. I wanted to copy. Okay, this number is 2000. Yeah, this is this. The first one is wrong. Okay, the left is that number. That's a big number. Now, why is that happening? Yeah, that's right. Right? The sprite as hexadecimal. To do that, we gotta we'll just do the whole thing. Pound 04x. Leave is write the leading OX. Add it to some, yeah. Okay, the sprites, nice. Right. Expand this up a bit. That's right. Okay. Now, because the screen is clear, There's something wrong. What is going on here? This first one's right. This one is very not right. This one is less right. This one is also wrong in a different way. What? Oh, that's what's happening. You see, yeah, I need to work on the different rows of the screen and actually, yeah. Actually, wait, where's Y being used? Only there. So we can actually move this into, okay. Equal. Now we don't need to add S everywhere. That's just the Y we're working with. Oh, look at that, it still failed. And I just got rid of those statements. Why did I get rid of those statements? Why? Why? Just print that out and see whatever. Warnings. Semicolon. There we go. All right. Now we're setting stuff. Beautiful. Now, what is this number? Invalid. Oh, no, it can't be. It can be a. There we go. That is. That. Ah. Yeah, so I was off by a little bit of the big scale there. Oh, hey, look at that. And this test even passed. And oh, I should make sure it's actually 0 on that. Fantastic. All right. That's great. The test was wrong. Which is the best kind of wrong. All right, and actually, since we have a working representation of a screen, there is one more thing we can do. We can clear it. So add in the test for that. What is it? 00E0. From at 200. We'll set something. Yeah. They're all 0. And we'll actually just set them in a loop. We'll just set everything to max. That looks good. Simple enough test. Should fail. I haven't written anything. Yeah. Left. Big number. Right. 0. These do not match. Fail the test. Perfect. So we go to clear screen, which just prints out clear screen. Did it print out clear screen? No. 00E0. Clear screen. Clear screen. Print line. Clear screen. I don't see that printed out. Okay. Did I mess up here? 00E0. Oh. Step. I should at least be erroneously printing out clear screen. Here we go. Clear screen. Okay, it's getting called. Everything's as it should be. This is easy. The exact same loop that I wrote. Only set it to 0. Screen cleared. All right. Perfect. That's gonna be the last function I work on for now. This has been like 2 hours. So I think that's enough. This is still very uncommented. That's actually probably something I should work on. This is This is not great to look at. There's probably, wait, 2 implementations. Oh, it implements. Yeah, whatever. Ops, shit. How did that get there? Yeah. And these are still all on the wrong rows. Whatever. That's fine. Yeah. So that's it for now. I will see all of you some other time. Goodbye.